everyone. Welcome back to another episode of the Engineering Quality Podcast. I'm Ali, and I'm joined by my co-hosts Royoli and Veronica. How is it going, team?
Hey Ali, hey Veronica. I'm pretty great today and super excited about today's episode. We're diving into a big topic, which is regression testing.
Hi, ladies. Same here. I think we are all excited to dig into this. Regression testing may not always sound glamorous, but it's one of the pillars of software quality.
Exactly. So how about we kick things off by explaining what regression testing is and why it is crucial for software development?
Sure thing. So, in simple terms, regression testing is all about making sure that new code changes don't break the existing functionality of the software. So, if you add a new feature, fix a bug, or even tweak something minor, regression testing ensures that everything else continues to work as it should.
Right. It's about catching those unexpected side effects. You fix one thing and you could break something else entirely. Without regression testing, you would not find out until it was potentially too late. Imagine fixing a small login issue and suddenly users cannot access checkout page anymore. That's the kind of chaos regression testing prevents.
Yeah. And regression testing also fits really well into the broader test strategy, making it an ideal candidate for automation because of its repeatability. So automating these test cases not only boosts the team's morale, because let's face it, no one really likes running the same test cases over and over again, but it also enhances scalability. By integrating these automated tests into the CI/CD pipeline, we enable the team to run tests after every change. This continuous feedback loop helps us ensure that our software remains stable and reliable over time.
Yes, and as you mentioned, automation really is key, especially in large, complex projects. And, as we get into this episode, we'll dig a little bit deeper into automation and how it applies to regression testing later. But before we get too far ahead of ourselves, can we talk about some real-world scenarios where regression testing is absolutely necessary?
I think it's a good idea. One of the most common scenarios is after fixing a bug. You fix one thing, but now you need to check that the fix didn't break something else in the application.
Yeah, the classic scenario, I fixed the login button, but now the shopping cart is now broken, right?
Exactly. It's wild how easily things can go wrong when one part of the code impacts another. That's why regression testing is needed anytime when there is a fix to the bug.
Yeah, and another big one is when you're adding or updating features. For example, you have a search feature and you release an update that allows for predictive searching, right? But if regression tests aren't run, you might break an existing part of the feature, like clicking on the search button or hitting enter no longer works.
Exactly. And also, let's not forget about third-party systems. When you integrate with an external API or service, their updates could introduce regression into your system that you didn't anticipate. So having regular regression testing running around your third-party integrations can really help catch these issues before they hit production.
Yeah, so true. And there are other systems or feature changes that should require regression testing. And these include code refactoring, which is when existing code is restructured to improve the code's efficiency or maintainability. And this does not normally affect the behavior of the system or feature, but regression tests would be necessary to confirm that. And then also for performance improvements. So to ensure that these improvements do not inadvertently break the existing functionality. Another example would be if there are server or environment changes. And I can give an example of this. I remember working on a project where we were using a server completely different from the other teams. And so we had a whole project around moving the application from one server to the next. But there was an environment secret key that was not updated, right? And because of this, the application did not work. And if we hadn't done regression testing, we would not have caught this before moving to production because everyone thought it was black and white, right? It was just as simple as moving everything from one point to the other. But it was the regression testing that caught that the secret environment key was not updated. And then even with patch releases, right, and updating dependencies for different libraries and frameworks, regression testing is still very important to ensure the updated components still work as expected.
Exactly. And now let's talk about types of regression testing. There are different approaches to regression testing. You have got a full regression testing where large parts of the system gets tested. That's more thorough, but unfortunately pretty time consuming.
Yeah, but who's got tons of time to test everything these days, right?
No
For
one.
that reason, most teams that I ever worked with anyway have chose faster iterations. So using a partial risk-based approach to regression testing, where the team analyzes what's being changed and make decisions on areas that should be covered. So they only really test the parts of the system that were impacted by the code or that were likely to be impacted by the code changes. It is quicker, but it still gives enough confidence that you didn't change anything that introduced any new bugs, or at least around the areas that we tested.
Yeah, and then again, that is why it's great to have your regression tests automated, right? It's especially important when you're dealing with a large code base, as I mentioned earlier, because automation allows you to run a set of predefined tests over and over, which is a huge time saver.
Yes, automated regression test suite is a lifesaver, especially in the continuous integration pipelines. It saves you time, runs consistently, and is scalable. You don't need a person who is going to perform it. Once you have written the scripts, every time you commit the code, those tests can run automatically to check that nothing broke.
Yeah, absolutely. So it's pretty intuitive that it is important to make sure that after any changes, nothing is broken in the existing system, right? But the real question really is, what should we include in our regression test suite? There is so much that could be covered in a regression test suite that sometimes I find that teams, and even myself included, find it difficult to decide what is it that we should have on our regression suite. How do we choose what to put in there? A lot of people would like to say that we need to put everything in there, that we need to test everything. But as we talked just before, we don't have time for that. But there are different ways, different strategies that we can employ to really decide what is the best areas that should be included in a particular regression suite. One example is critical business functions, for example. Basically, you need to make sure that the core features of applications are covered. So talk to your PMs, talk to your squads, talk to your product people, and decide which parts of your system are really the most critical ones, that if a bug was raised in that area, it was going to be a P1. So you need to make sure that those areas are covered. For example, payment systems, if you have an e-commerce website, if that's down, big problems. So you need to make sure that you have tests that cover that. Reporting, maybe not. You don't know that depending on the system, but it's important to make sure it's a team decision and that you spend time with the team thinking about what parts of your software is actually critical.
Exactly, Ellie. And it's not just about the big crashes. Even small issues in key areas can lead to big consequences. So always prioritize testing those high-risk areas where failures could cause serious harm. You should also include common user flows to your regression suite. Those are the pathways users take the most, like logging in, browsing, adding things to cart, stuff like that. You cannot afford to have anything break in those areas.
Exactly, Veronica. If a common action like submitting a form or saving a document suddenly stops working, you're going to hear about that pretty quickly. And so the regression tests should ensure those everyday workflows stay smooth. Another must-have is tests for recently fixed bugs. And, we've all seen it. You fix a bug, push it to production, and boom, it's back. A good regression test suite catches those repeat offenders before they show up again. And that's why adding test cases for those past bug fixes is so important. If you fixed it once, you don't want to fix it twice.
So true. Another area that I always like to cover as well are integration points. And we talked a little bit about this earlier today because they ensure that different parts of your system are communicating correctly. So whether it's APIs, third-party services, or databases, if one component fails, it can disrupt the entire system. So the goal isn't just to verify that individual parts work, it's to confirm that everything fits together smoothly and continues operating as usual. Especially third-party services and its integrations, they are crucial for preventing system-wide chaos.
Now, we cannot forget about backwards compatibility tests. If your software needs to work with older version, it's critical to make sure new code doesn't break all functionality. Even if you're pushing new features, some users might still be on older versions. You have got to make sure everything stays functional for them too.
Exactly. And we should also include tests for some common edge cases. So these are the rare situations that might not happen often, but could cause issues if they do. Like, what if someone enters a password that's 256 characters long? It might seem trivial, but it could lead to some pretty weird bugs if missed. And I'm sure we've been on those calls with these race conditions that are caused by something so simple that also could have been caught with proper regression testing. So, very important.
Yeah, a very common thing is when some special characters are not being handled. So if special characters are not being properly handled and it just can crash application, well, it doesn't happen right now as much because I feel like everyone is using those masks right now. So what I'm trying to say is right now we have additional guards in place when engineers can use already pre-implemented masks for example, email or phone number that will filter out the characters that are not permitted. And it helps a lot with this kind of issues. Luckily.
Yeah, absolutely. I think there is no doubt in most people's minds anyway that regression testing is really important. Okay, so we've talked about the importance of regression testing and the different types of regression testing and what we should typically include in the whole regression testing suite. So as with most things in software development, it's a trade-off and it comes with its own set of challenges as well, right?
Oh, for sure. And one of the biggest challenges is time, as we mentioned. So a full suite of regression tests can take hours to run.
Mm.
And sometimes teams just don't have the luxury of time when they're pushing for a release.
Yes, I agree, really. Sometimes it happens that some testers are just stuck with doing regression testing over and over, and it's like a Groundhog Day. Every day, Groundhog Day, unfortunately. And then there is another issue with regression testing, which is test maintenance. Over time, automated tests can become brittle. The software evolves and sometimes tests break, not because there is a bug that was introduced to application, but because the test itself needs to be updated, meaning that functionality has been changed intentionally, but the tests were not updated. And it can be a headache to keep them in sync with an actual code if engineers are not helping with that.
Yeah, absolutely. Yeah. One other thing that I've encountered, we've all encountered with regression testing as well, is when the regression test suite becomes unreliable, when it's too flaky, that people stop paying attention to them. It's another problem because let's say you have 2 or 3 test cases that are always failing there. People start losing faith on the regression test suite because they're saying this is too flaky. And actually, in a recent place I've worked at, we had a good suite of regression test cases, but a few of them were always failing randomly. So, flakiness within the tests. So before we removed them from our suite, there was a problem in production that could have been caught by that suite and actually was caught by the suite. the test case actually failed. But because we had flakiness on that suite before, no one paid attention to it. So when we went back to look at those test cases, the regression suite was good. It picked up the issue. He failed. Everyone ignored it. We just pushed it to production regardless. And then we realized that, hey, it was a test case that it didn't used to fail before. It failed on the right thing. So one thing that it's really important is to really make sure that those test cases that are flaky are removed from your test suite, because you don't want people to lose faith in the whole suite and then let those tests that are failing in picking up the right things to go through as well. So that's another challenge that I have with regression testing too, because again, like both of you mentioned, like, it takes so much time also to maintain these regression suites that it gets to a point where there was too many test cases there, one or two gets flaky, we just brush over them. But yeah, I'm not sure if you guys had that before.
Oh, yes. Of course. I feel like everyone have seen it. Unfortunately, it's a very common issue. So flaky means that sometimes test fails, sometimes test passes, regardless of changes that have happened to the code. But the flakiness can come from different sources. It can be the test itself, that it doesn't, for example, find the component in the unique way, or it can be an environment that the test is running at. And well, there is nothing the test can do about the environment it's running at, because test cannot affect environment. So, for example, mostly when I talk about environment, it's usually back end that might be not functioning or might be slower. And as a result of that, we are running into timeouts in the test. But at the end of the day, the test is being called flaky, but it's not really a test's fault that it failed. It's an environment. And unfortunately, sometimes those, like, for example, environments problems are being internalized as a test problem. And it's really hard to gain the trust for the test suite again, even though the test was failing not because of the test itself, unfortunately. And right now, not many companies have different environments for testing and pre-production environments, which is called staging. Everything going on in one environment, and as a result, it's obviously not stable because everyone is pushing to this environment. Many teams are working with the same environment. And as a result, it's a recipe for disaster.
Yeah, that is one of my pet peeves when we hear from others in our team saying, oh, your regression suite is just flaky. And it's like, well, no, our environment's flaky. If we had an environment that we could control, or that it was not being merged into all the time, that if the goalpost wasn't being moved, my tests would probably be less flaky than what they are right now. So there is a huge difference between tests being flaky and environments being flaky, but it's hard to pinpoint those differences as well. So, yeah.
Another reason for potentially tests being flaky is pre-setup that needs to happen for the test. So, for example, we need to assemble the application before we can run the test. And if the assembly of application fails, then obviously entire test suite would also fail because there is nothing to access to.
Yeah, so true.
Yeah, and as a result, again, test suite is red. Test suite failed, but it even didn't run. Well, it tried, but there is nothing to run on.
Exactly.
And then, of course, there are situations where the test fails, not because of environment, but because of the test itself. Like, it could be the order of the test, right? You have one test that's dependent on another test to run. And if somehow the order is changed, obviously the tests are going to fail. And then when you have a lot of people who have access to the same code base and to the same test and who can make changes, it's hard to control if the order is changed or things of that nature, or if somebody hard-coded a wait time for a test and the test needed 61 seconds and somebody hard-coded 60 seconds, it's going to fail, right? So it's just very important to make sure that these things are addressed to remove the flakiness so that the teams can trust the tests.
Yeah, I want to also say one thing about order of the tests. Ideally, all tests has to be independent. So they should not be relying on each other. And if they are, it's already an anti-pattern.
A bigger problem, right?
Yeah.
Exactly.
So, we all understand how good regression testing is, but there is also lots of challenges with it, like with everything else in engineering. So how can we mitigate some of these challenges with regression testing? The fact that it's time consuming, that it can be resource heavy and somewhat of a nightmare to maintain. There are different ways that we can do. We mentioned a few already, but there is other ways, even including planning how the systems are architectured together as well, that could also improve how the regression testing is run and planned as well. So let's dive into a few key patterns that can make a huge difference in cutting down the number of regression bugs.
Yeah, let's do that. First up, we have got microservices architecture. This pattern is all about breaking down a large monolithic applications into smaller, independent services that can be developed and deployed separately. The beauty of microservices is that each service is self-contained. So if we are making a change to, say, the user authentication service, we can focus regression testing just on that service rather than testing the whole system. That really narrows down the scope and cuts back on potential bugs elsewhere.
Yeah, another powerful pattern is API first development. With this approach, we design our APIs before building the system, treating them as a contract between components. This means that once the API is tested and locked down, changes to internal components behind that API don't mess with the rest of the system. And so with API first, if our backend logic changes, but the API contract stays the same, we're a lot less likely to introduce regression bugs to the rest of the system. And it's a great way to isolate potential issues.
Yeah, absolutely. I agree. And there is another way as well. It's feature toggles or feature flags. And by the way, if you want to know more about feature flags, don't forget to check out our continuous integration episode. We talk a lot about that there. But, feature flags allows us to turn features on and off in production without developing new code. And it's perfect for rolling out changes gradually. So using feature toggles, we can test changes in isolation as well. And if something goes wrong or a regression bug pops up, we can always just flip the feature off and there is no need for an emergency rollback.
Yeah, it sounds like a dream.
Right?
Luckily, it's being used more and more across companies, so it's kind of becoming a best practice. Another existing architectural pattern that can help with a reduction to regression testing time is serverless architecture. This approach eliminates the need to manage infrastructure at all. And each piece of code or function operates completely independently. And this isolation is key. If we update one function, like the one that handles file uploads, it won't affect another function that, say, generates reports. That drastically reduces the risk of regression bugs.
Exactly. And lastly, we've got event-driven architecture. This one's really cool. So components communicate by producing and consuming events, meaning they don't depend on each other directly. And because everything is decoupled, changes in one component doesn't necessarily require changes in others, which naturally lowers the risk of regression bugs spreading through the system. Think of a payment system that processes transactions through events, right? It doesn't directly affect the inventory system. So if we introduce a change in one, we're not automatically risking breaking the other.
It's super cool. And, there is lots of other different architectural patterns as well. These are some of the main ones that can have a big impact on finding regressions and regression bugs. And those architectural patterns are not just reducing the scale of regression testing, but also making our systems more resilient to bugs as well. So it's all about smart planning and testing early and often.
Well said, Ali. Nice way to sum it up. Planning, testing early, and testing often.
Yeah.
Now let's talk about best practices for a second, right? So one thing we always recommend is to start small and automate gradually. You don't need to automate everything at once. Let me say it again. You do not need to automate everything at once. Focus on automating the tests for your most critical functionality first. And as you build out your suite, you can add tests for less critical features over time.
Totally. Plus, avoid automating too soon. When a feature is still in development, things can change frequently, and likely they will change, which means testers might end up doing double work or maybe sometimes triple work. Yeah, you will also likely see a lot of false positive failures in CI pipeline if you automate before feature became stable.
Yeah, so true. Another best practice is to implement a risk-based approach. Just ask yourself, what's the worst thing that could happen if this feature breaks? And those are the areas that need the most attention during regression testing.
All right, that's a wrap for today's deep dive into regression testing. We have covered a lot of ground, from the basics to the real-world challenges.
Yep, and remember, regression testing isn't just about finding bugs. It's about ensuring the quality and stability of your software over time. It's what makes sure your users have a smooth experience no matter how many changes you introduce.
Yeah, and it's the unsung hero behind the scenes catching those sneaky bugs that could otherwise wreak havoc. And the best part is that with modern architectural patterns and automation, it's easier than ever to integrate regression testing into your workflow without slowing down your team. So now we move on to our segment mailbag question. Now it's becoming one of my favorite segments when we answer a question from the audience. So our mailbag question of the week is, how do you handle regression testing for a large code base with frequent updates? So who wants to take this one?
I can give it a go. Handling regression testing in a large code base with frequent updates definitely has a lot of challenges. For one, managing the sheer volume of tests can be overwhelming. Consolidating a lot of what we just mentioned above, one approach I find effective is dividing tests into smaller, manageable sets or microservices. This can help target the highest impact areas with every release cycle rather than running the entire suite each time. It saves time and also helps us keep a closer eye on critical functionalities without overwhelming the CI pipeline.
That's a great point, Veronica. Along those lines, I'd say leveraging selective risk-based regression testing can be a game changer. By running only the tests that are likely affected by recent changes based on code dependencies or recent commits, we can balance thoroughness with efficiency. And of course, this approach requires robust test automation to keep things moving at the pace we need, especially when releases are frequent.
Yeah, it's definitely a challenge. Working with old code, especially when you don't have those engineers working at the company anymore, it becomes a mysterious part of the system. It's really difficult, but those are great tips. Thank you. All right, now it's time for our tip of the day. Today, we are talking about smoke testing.
Yes, we are. And what is smoke testing, you would ask? Well, smoke testing is a quick check of your system's most critical features, kind of like making sure your car engine starts before hitting the road. It's a simple test to ensure the basics are working before diving deeper.
Exactly. It saves time by catching obvious major issues early so you don't waste effort on a broken build. You can even automate smoke tests in your CI/CD pipeline for fast feedback after each deployment. I love doing it that way.
Yeah, I think these days it's the only way to do it. So remember that smoke testing is all about verifying stability before going deeper. Don't skip it. You definitely thank yourself later.
By the way, this term, smoke testing, do you ladies know where it originated from?
No, I don't.
No,
actually.
you don't? So it actually came from plumbing. So what happened, I don't know which years, a long time ago. I don't think they do it right now anymore. Maybe they do, I'm not sure. But when plumbers finish their pipes, they put on the smoke inside the pipes and was checking for leaks like that. So if the smoke is coming out from any part of the connections. This is how they will see in potential leaks. So it's not like water leaks.
Wow.
So it's smoke leaks instead.
Veronica, I love how you always
something.
have the history of all these terms.
Exactly.
I don't know where I know it from, honestly.
I think another thing that's worth mentioning is a lot of times people use smoke testing and sanity testing interchangeably. And there is somewhat of a difference, right? So like smoke testing is what you would do to ensure that the overall build is ready for testing. Like we mentioned, while sanity testing checks the specific changes or fixes, checks that they do not introduce new issues. So, both are efficient ways to catch problems early, but there's just that slight difference with smoke versus sanity.
If we talk
the
about
focus is different.
Yeah, I think the good way to put it is smoke testing doing a broad check of entire system that it works, and a sanity test doing a deep dive into specific areas to check that the changes has not affected anything within a specific area.
Exactly.
All right, and this wraps up today's episode. We would like to hear from you, our listeners. Have you had any regression testing horror stories or success stories? Maybe you have got a favorite tool or techniques you use. Share your thoughts and experiences with us.
Or if you have any burning questions about regression testing or something that you want to see us talk about regarding regression testing, we'd love to be able to answer them in a future episode. So hit us up on our social media or drop us a message on our website.
And don't forget to subscribe to our podcast for more insights and discussions on software testing and engineering. And of course, follow us on Instagram at engineeringquality_podcast. That's engineeringquality_podcast. And on X, formerly Twitter, at engineeringqual. That's one word, engineeringqual, QUAL.
Thanks for tuning in. Stay curious, stay bug-free, and we will catch you in the next one.
Bye, everyone.
Bye, everyone.